Here's something most people don't realize. California has already been hit by a double earthquake, and it happened more recently than you'd think. In the summer of 2019, the ground near a desert town called Ridgecrest ruptured not once, but twice. First, a powerful earthquake struck, and then, a little over a day later, an even bigger one hit the same region. A genuine 1-2 punch that shook Southern California harder than anything had in 20 years. Fortunately, it struck a sparsely populated desert area, so the damage, while real, was limited. But it left seismologists with a chilling question that they are still working to answer today. What happens when a double earthquake like that strikes not an empty desert, but a major city? Because scientists now believe that these paired earthquakes, where one great quake triggers or is followed by another, are a genuine threat to California's most populated regions. And they've been running detailed simulations to figure out exactly how bad it could be. So today, we're going to break down what a double earthquake really is, the ones that have already happened, the terrifying scenarios scientists have modeled, and what they're watching for next. And let me be completely upfront with you. No devastating double earthquake has struck California today. This isn't about a disaster that just happened. It's about a real, studied threat that scientists are actively preparing for. I'm going to give you the honest, accurate picture because this topic attracts a lot of fear-mongering, and the truth is compelling enough without any exaggeration. But before we dive in, do me one quick favor, because it genuinely helps this channel. Drop a comment right now and tell me where you're watching from. And if you're in California, how prepared are you for a major earthquake? Honestly, do you have a kit, or have you been putting it off like most of us? Be honest, I read every comment. And if you want the calm, accurate breakdown of these events instead of the internet panic version, hit that subscribe button. It's free, it takes 1 second, and it means you'll always get the truth over the hype. A thumbs up helps push this out to more people who deserve the straight facts. All right, let's get into it. Let's start by understanding what a double earthquake actually is, because the term gets used loosely, and precision matters here. In seismology, there are a few different ways two quakes can be related. Sometimes a smaller earthquake, called a foreshock, precedes a larger main shock. Sometimes a big earthquake is followed by a smaller aftershock. But the truly dangerous scenario, the one scientists are most concerned about, is called an earthquake doublet. When one large earthquake, magnitude 7 or greater, is followed within hours or days by another large earthquake of comparable size on the same or nearby connected fault. Two great quakes back to back. That's the kind of double earthquake that can turn a disaster into a catastrophe, and it's the focus of everything we're discussing today. So let's go back to that real California example, the 2019 Ridgecrest sequence, because it's the proven precedent that made scientists take this threat so seriously. On the 4th of July, 2019, a magnitude 6.4 earthquake struck in the Searles Valley, near the town of Ridgecrest in the Mojave Desert, about 150 miles north of Los Angeles. That alone was a significant quake. But then, roughly 34 hours later, on July 5th, a much larger magnitude 7.1 earthquake ruptured in the same area. The first quake, it turned out, had been a foreshock to the second, larger one. Together, they were the strongest earthquakes to hit Southern California in 2 decades. They caused fires, gas leaks, damaged buildings, and cracked roads and highways in the Ridgecrest and Trona areas, and they were felt by millions of people across the region, all the way to Los Angeles and beyond. Remarkably, because the epicenter was in a remote desert, there were no direct deaths, a stroke of geographic luck. The Ridgecrest sequence also hammered the nearby Naval Air Weapons Station at China Lake, one of the military's most important research and testing facilities, causing significant damage and temporarily knocking it out of operation. A reminder that earthquakes threaten not just homes, but critical infrastructure. And the sequence didn't stop with those 2 big quakes. It unleashed a torrent of aftershocks. Tens of thousands of smaller tremors rippling through the region over the following days, weeks, and months, keeping residents on edge and giving seismologists an extraordinary flood of data to study. For scientists, Ridgecrest became one of the most closely analyzed earthquake sequences in California history, precisely because it was a real, modern, well-recorded example of the complex, cascading, multi-fault behavior they most wanted to understand. But here's what made Ridgecrest so scientifically important, beyond just being a double earthquake. When scientists studied the ruptures, they discovered that the quakes had broken along a complex network of interconnected faults, including faults that hadn't even been mapped before. The earthquakes revealed a hidden, tangled fault system, with the ruptures jumping and crossing between different fractures in ways that challenged the textbook understanding of how earthquakes behave. It was a vivid, real-world lesson that California's faults are more interconnected and more capable of complex, cascading ruptures than we fully appreciated. And that lesson feeds directly into the fear of a doublet striking a city. Because if faults can trigger and cascade like that in the desert, they can do it under a metropolis too. Now, to understand just how deadly a doublet can be when it hits a populated area, we need to look at the tragedy that truly galvanized scientists on this issue: the Turkey earthquakes of February 2023. In the pre-dawn darkness, a catastrophic magnitude 7.8 earthquake struck southern Turkey and northern Syria. It was devastating on its own, collapsing buildings and killing thousands. But then, just about 9 hours later, while people were still trapped and rescue efforts were only beginning, a second enormous earthquake, a magnitude 7.5, struck on an adjacent connected fault. This was a textbook earthquake doublet, and its effects were horrific. Buildings that had been damaged and weakened by the first quake collapsed entirely in the second. The already overwhelmed emergency response was thrown into chaos. Rescuers became victims. In the end, that doublet contributed to the deaths of tens of thousands of people. It was one of the deadliest earthquake disasters in recent history, and it demonstrated, in the most tragic way possible, exactly why a double earthquake is so much more dangerous than a single one. To grasp the scale, those two Turkish earthquakes struck along the East Anatolian Fault system, a major boundary somewhat comparable in tectonic terms to a fault like the San Andreas. The rupture tore across hundreds of miles, affecting a region home to millions of people in multiple large cities. Whole apartment blocks pancaked to the ground. The disaster ultimately damaged or destroyed hundreds of thousands of buildings and displaced millions of people, in addition to the horrific loss of life. It played out in bitter winter cold, which made survival for those trapped and those left homeless even more desperate. For seismologists watching from California, the parallels were impossible to ignore. A major strike-slip fault system, a doublet of great earthquakes on connected faults, and a dense population caught in between. It was, in many ways, a preview of the very scenario California most fears, which is exactly why it triggered such an intense wave of scientific study and preparation on this side of the world. The Turkey doublet transformed the double earthquake threat from an academic curiosity into an urgent, concrete priority for the people whose job is to keep California safe. And that disaster prompted a direct and urgent question among California's earthquake experts. What would happen if a doublet like Turkey's struck one of our major cities? So they did something about it. They built detailed computer simulations to find out. Working with agencies, including the U.S. Geological Survey and California's Emergency Management Office, scientists modeled hypothetical earthquake doublet scenarios in California's two biggest population centers. In the Los Angeles region, they simulated a doublet on the Newport Inglewood and Palos Verdes faults that run right through densely populated parts of the LA basin. And in the San Francisco Bay region, they simulated a doublet on the Hayward and Calaveras faults, which threaten the heavily populated East Bay. These aren't random choices, they're real major faults, capable of large earthquakes running directly beneath millions of people. And each of these faults carries its own ominous history. The Hayward Fault, which runs right through the densely populated East Bay cities near San Francisco, last produced a major earthquake back in 1868, an event so significant it was once simply called the Great San Francisco Earthquake, before the even larger 1906 quake claimed that title. Scientists consider the Hayward Fault one of the most dangerous in the country precisely because it runs directly under so many homes, and because it's been building stress for over a century and a half. The Newport Inglewood Fault in the Los Angeles basin, meanwhile, was responsible for the deadly 1933 Long Beach earthquake, which killed dozens of people and famously led California to strengthen building codes for schools. So when scientists chose these faults for their doublet simulations, they weren't picking obscure fractures. They were modeling catastrophes on the exact faults that have already proven capable of killing people. Now imagine striking and devastating pairs beneath cities far larger and more crowded than they were decades ago. The purpose of these simulations was to understand the cascade of effects unique to a doublet, the very thing that made Turkey so deadly. Consider the grim logic the scientists had to model. The first large earthquake strikes, and across the city, buildings are damaged but left standing. Cracked, weakened, structurally compromised, but not collapsed. People evacuate into the streets, or they shelter in place, or rescuers rush into damaged structures to help the trapped. And then, hours later, the second great earthquake hits. Those weakened buildings already pushed to the edge now collapse. The people who returned inside, or the rescuers who went in, are caught. The emergency response, already stretched across a massive disaster, is doubled and thrown into disarray. Water and power systems, damaged in the first quake, are knocked out entirely in the second. This is why a doublet isn't just twice as bad as a single earthquake. It can be far worse because the second quake exploits all the vulnerability created by the first. The simulations let planners estimate the ground shaking, the potential damage, and the cascading impacts, so that emergency services can prepare for this specific, brutal scenario rather than being caught off guard by it. It's worth appreciating what goes into these simulations, because they're a genuine feat of science. Researchers build detailed computer models of the ground beneath a region, the faults, the rock, the loose sediment in the basins that can amplify shaking, and then simulate, second by second, how the seismic waves from a hypothetical rupture would travel outward and shake the surface across the whole city. The output includes realistic maps of exactly how hard the ground would move in each neighborhood, which can then be fed into models that estimate building damage, casualties, and losses. By modeling a doublet, scientists can capture that crucial compounding effect, running the second quake's shaking on top of the damage the first one already caused. These simulations don't predict when a quake will happen, but they give emergency managers, engineers, and city planners something invaluable: a realistic dress rehearsal for a disaster that hasn't happened yet, allowing them to identify weak points, plan evacuation and rescue logistics, and strengthen the systems that would be tested to their limits. In a very real sense, this science is a way of learning from a catastrophe before it ever strikes. So why is California particularly susceptible to these double earthquakes? It comes back to something we're learning more about every year. California's faults are deeply interconnected. The state isn't crossed by a few simple, isolated cracks. It's laced with a complex branching network of faults that interact with one another. When one fault ruptures, it transfers stress to its neighbors through the surrounding crust. And if a neighboring fault is already loaded and near failure, that stress transfer can push it over the edge. We saw exactly this cascading behavior at Ridgecrest, where the ruptures jumped between multiple faults. And recent research has only deepened this picture. Scientists have found evidence that even California's two greatest fault systems, the San Andreas and the offshore Cascadia subduction zone, may have ruptured in sync at times in the geologic past, raising the possibility that a Cascadia megaquake could trigger the San Andreas in a truly enormous double event. On top of that, a major study recently found that the southern San Andreas and San Jacinto faults are under more stress than at any point in the last 1,000 years, meaning the system is loaded and, in the loose language scientists use, overdue. Put it all together, an interconnected fault network, documented cascading ruptures, stress at millennium highs, and evidence of past synchronization. And you can see why the double earthquake threat is taken so seriously here. Now, and this is the most important part, where I refuse to cross into fear-mongering. Let me give you the honest caveats, because the responsible scientists insist on them. First, earthquakes cannot be predicted. Nothing in any of this research can tell you when the next big quake, single or double, will strike. It could be tomorrow, it could be a century from now. These studies help us understand what's possible and how bad it could be. They do not put a date on the calendar. Second, a doublet is a possibility, not a certainty. Many, probably most, large earthquakes occur without triggering a second great quake. The Ridgecrest and Turkey events show doublets can happen, and the simulations show what they do. But they are not the guaranteed outcome of the next big one. Third, the small earthquakes and swarms California experiences all the time are not secret warnings that a doublet is imminent. California has thousands of tiny quakes a year, and they are almost always just the normal background hum of a seismically active state. So the honest posture here is not panic, it's informed preparation. Scientists aren't ringing an alarm bell that says, run. They're doing the careful, sober work of understanding a real threat so that we can all be ready for it. And readiness is genuinely the whole point, because here's the empowering truth. Whether the next big earthquake comes alone or brings a partner, the steps you take to protect yourself are exactly the same, and they work. So let me give you the practical game plan with one crucial addition specific to the doublet threat. Start by securing your space, because most earthquake injuries come from falling objects, not collapsing buildings. Bolt tall furniture and bookshelves to the wall. Strap down your water heater so it doesn't topple and rupture a gas line. Secure heavy items, and don't hang anything heavy over your bed. Next, build your emergency supplies, at least several days worth. Ideally a week or two of water, non-perishable food, a manual can opener, a first aid kit, flashlights, batteries, and any essential medications, because services can be down for a long time after a major quake. Keep sturdy shoes and a flashlight by your bed for the very real hazard of broken glass. Learn and practice the response. Drop, cover, and hold on when the shaking starts. Drop down, get under a sturdy table, and hold on until it stops. If you're in California, enable the Shake Alert Earthquake Early Warning on your phone, which can give you precious seconds of notice before the shaking arrives. Have a family communication plan with an out-of-state contact and a meeting place, since local networks often jam. And if you live in an older home, seriously consider seismic retrofitting, bolting the structure to its foundation and reinforcing weak points. Now here's the doublet-specific lesson, drawn directly from Turkey and from the scientists' scenarios, and it could save your life. After a major earthquake, do not assume the danger is over and do not rush back into damaged buildings, because a second large quake could follow within hours or days, and a structure that was weakened but survived, the first quake could collapse in the second. So after a big one, if a building is visibly damaged, stay out of it. Be extremely cautious about re-entering any structure. Expect that strong aftershocks, or potentially another main shock, could come, and give the ground time before you let your guard down. That single piece of knowledge, treating the aftermath of a great quake as an ongoing danger rather than a finished event, is one of the most important takeaways from everything scientists have learned about double earthquakes. So what exactly are scientists watching next? They're studying the interconnected fault networks beneath California's cities in ever finer detail, mapping how stress moves between faults and which ones are most likely to trigger their neighbors. They're refining those doublet simulations for LA and the Bay Area to sharpen emergency planning. They're monitoring the stress building on the San Andreas and San Jacinto systems, now known to be at 1,000-year highs. They're investigating the possible link between the San Andreas and Cascadia at the northern end of the state. And they're tracking the constant, subtle seismic activity across the region for any insights into how the whole system is behaving. It's an enormous ongoing scientific effort, not to predict the unpredictable, but to understand the threat well enough that when the ground does move, California is as ready as it can possibly be. This work also feeds directly into practical decisions that touch everyday life, how building codes are written and updated, which older structures get prioritized for mandatory retrofitting, where hospitals and fire stations and bridges need reinforcing, and how utilities protect the water, gas, and power lines that cross active faults. Every insight from a study like the doublet simulations can translate over time into a building that stays standing, a pipeline that doesn't rupture, or an emergency plan that saves lives. That's the quiet payoff of all this research. It may not tell us when the next great quake will strike, but it steadily makes the places we live more resilient for when it inevitably does. Science can't stop the Earth from shaking, but it can help ensure that far fewer people are hurt when it happens. Here's the honest bottom line. No double earthquake devastated California today. But the double earthquake threat is real. It's studied, and it's exactly what scientists are watching. California has already experienced a doublet at Ridgecrest in 2019, which revealed just how interconnected and complex the state's faults truly are. The tragic Turkey doublet of 2023 showed the world how catastrophic these paired events can be when they strike populated areas. And in response, scientists have modeled detailed doublet scenarios for Los Angeles and the San Francisco Bay Area, revealing the brutal way a second great quake can multiply the devastation of the first. The threat is genuine, rooted in California's tangled fault network and its stress at 1,000-year highs. But earthquakes still can't be predicted. A doublet is a possibility rather than a certainty. And the recent small quakes aren't a countdown. So the answer isn't fear, it's preparation. Get your home and your family ready, know what to do when the shaking starts, and remember the hard lesson of the doublet. After a great quake, the danger may not be over. Being ready is the one thing entirely within your control. And it works no matter what the Earth throws at us. I'm going to keep tracking all of it. The science, the simulations, the faults, and everything we learn about how California's ground really behaves. If you want the calm, accurate version instead of the internet doom machine, subscribe so you don't miss an update. Because with a topic this surrounded by fear and misinformation, having someone give you the straight story is the whole point. Hit that like button to help this reach more people who deserve the truth instead of the hype. And maybe it nudges someone to finally build that emergency kit. And drop a comment. Where are you watching from? And are you prepared for a major earthquake? Be honest. I read every single one, and I'll see you in the next one. Stay safe out there. Take an afternoon this week to get ready, and look out for one another.